Namaskar, Didi. So I will introduce Dr. Michael Owen. Dr. Michael Owen is a chiropractic physician with emphasis on clinical nutrition, applied kinesiology. I think that's a science of movement and internal diagnosis. And his topic will be digestion, elimination, detoxification, my observation from clinical practice point of view. So welcome, Brother Mukunda.
Hello, namaskar. I hope you can hear me. Okay.
Yes, we
So, all right, good, thanks. So my brief talk is really from a Western point of view and from a holistic chiropractic mindset. And in terms, well, I'm going to be talking a lot about digestion and detoxification. And certainly the mind and the gut have a huge connection, as we're finding out more all the time. So a lot of illnesses in the gut really start in the mind, and a lot of gut illnesses actually go up to the brain, and so it kind of goes back and forth. So so my agenda is I'm going to do like a little disclaimer, and then I'm going to talk about my MBAs, my most basic assumptions. And then I have a little story to tell that if you can, well, it's a story I learned about 30 years ago before I started my formal education, and it's now becoming more and more important all the time. So I want to share that with you. And then I'm going to go over digestion from north to south, and I'll talk about all the different parts that happen in the different parts of the tract. So okay, my disclaimer. So this is my opinion and my observations, and it's not to be taken as a way to diagnose or treat anything. So I urge you to work with your physician or your healthcare provider that you've been working with before you try anything. All right, it's just opinion here. So so the first MBA, or most basic assumption, is really more of a framework, and it really helps to get this, to understand everything we're going to be talking about. And it's the idea of an open system. So an open system is any system that is self-regenerating and it can grow itself, like a body or a cell or a company or a nation or anything. Any system has to be able to maintain an inner structure and to regenerate itself. And these systems are open systems. In other words, they take things in and they repair and grow, and then they eliminate waste products or any other functional things too. So I guess the most basic one is, you can imagine a cell, a classic cell, which would be a circle with a smaller circle inside. And so the circle would be, okay, it's a cell, a representation of a cell. Now we know that cells really have all different kinds of shapes. But if we just think of the classic representation of the inner nucleus, is what we used to think of as the brain of the cell. But now we know through research that it's really not the brain of the cell. It's not the intelligence at all. It's really the gonads. It's really the reproductive organ of a cell. And the intelligence of a cell is at the border, the membrane. The part that separates the cell internal from the outside world is where the intelligence is. So that a cell needs to take in material into itself in order to heal and grow and repair, and it needs to eliminate waste products. Well, we're a system that's a lot more complex than that. And I would say that our digestive tract represents our membrane and our connection to the outside world. So that when you swallow something, it's really not inside of you yet until you absorb it through membranes. So this inner tract that goes from the mouth to anus is about 4 times longer than you are tall. So if you're 5 feet tall, you have about 20 feet of intestines, stomach, and colon inside of you. If you're 6 foot tall, it's maybe about 24 feet, which is, it's pretty long, and it's a lot of real estate to manage. So we're going to call that the digestive tract. And it's important to note that when we swallow something, it's really not in us until we absorb it through our membrane. And these membranes in our digestion system have to discriminate from what we want that's nutritious and helpful, and what we don't want that's a pathogen or a toxin. So we'll talk more about the intelligence of our membranes in our digestive system as we go. So, so my next point, so I have 8 MBAs. That's the first one. It's that we're an open system. We need to take things in. We need to get things out. There's one more point, I think, in terms of input. We can think about purely chemical, food and digestion, but also input in terms of, the entertainment we have and the company we keep. All of these things are inputs into our system. And if we have a degenerated environment with degenerated entertainment and poor food and poor company, it's really hard to maintain a good system. So pay attention to the inputs, particularly, like I said, entertainment, and well, we're going to talk about food here too, but all inputs have to be managed with our intelligence. So the second point I want to say is that most illness starts in the GI tract. Most illness starts in the GI tract. So when you have somebody who ends up with cancer at some point in their life, there's usually going to have been some sort of a digestive colon problem or a liver problem that would then later, over years and years, develop into cancer. We know that most of our immune system is actually in the GI tract. So if the GI tract is filthy, our immune system is pinned down and it's hard to maintain health. So that's the other point. Okay. And let's say that there is an illness that you have that isn't from the GI tract. That does happen. But many of these illnesses will also then affect the GI tract secondarily. So if you have anything really, it might make you sad or depressed or some sort of imbalance emotionally, and that would actually show up in your GI tract as a problem secondary to another illness. So the GI tract is really involved in illness as either a cause or as an effect. Okay, and the next point is, if you eat artificial food, you're going to make an artificial body. And when I say artificial food, I'm talking about processed foods. I'm talking about foods that have, flavor enhancers and colorings and preservatives and all of these chemicals, which are not really feeding your body at all. They're there to make the food, more to look better and taste better, but really they provide no nutrition. So we have to really take care that we're eating healthy, quality, fresh food. And that's kind of an obvious point, but it's missed by most people. They think they can just stop by at the drive-through and get a sack of whatever they call food, and that somehow they're going to be healthy. So, okay. So anyway, so if you eat artificial food, you're going to have an artificial body, and you're not going to be healthy. So the point is that diet is extremely important that we get the good nutrition to feed our body. And we have to keep in mind that there is, biological individuality. One person's diet might be really right for them, but somebody else may not be able to handle it for whatever reason. Humans are quite diverse in our ability to take in different foods. We're not all zebras, which have like almost identical sort of genome expressions. We're so vast and so complex that, I'm not going to say, oh, you need the South Beach diet or you need the keto diet or whatever. There's so much bioindividuality. And so the question becomes, how do you find the right diet for you? Well, I think that's going to be my story I'm going to tell in a moment. And then the next point is that a healthy diet may change over time as one becomes healthier or not. it can change. So, don't get stuck on, oh, this is the diet. It could shift. And I guess the last point about my MBAs is that the intestinal flora is so important for your emotional health, for your how you balance yourself in the world. What sort of things you crave. I work a lot with Candida and SIBO, that's small bowel, small intestine bacterial overgrowth. I work a lot with parasites and a lot with viruses. And these critters that we all have can actually influence your desire for different foods that actually suit them. So this flora is vitally important. We need to really take care of the flora like a garden. And just to know that if you count all the cells in your body and you compare it to all the cells of the intestinal bacteria, and we call the biome, there's actually more of them than there are of us. There's more cells in your body that are bacterial, viral, parasitic, candida, fungal, than there are cells that make up your body. So they're tremendously important. And when we get the right flora, it'll help us to be much more healthy. So now to my story. This story came to me before I started my formal education. And I thought, well, what a charming, cute little story. And it's really taken me about 30 years to really understand how important it really is. So let me go with this. So one day, all of the organs were sitting around having a conversation. So it's a parable. So the organs, the heart, the liver, the lungs were sitting around chewing the fat, as we say. And as conversations sometimes go off the rails, they're getting a little braggadocious about that. And it came to the point of like, well, which is the most important organ? And, they all had a different take on that. And so the heart says, well, of course, I'm the most important organ. I'm the heart. I beat every second of every day of your whole life. And I'm the most important organ. I pass blood through to all the cells of the body. I nurture and feed them. And a little sidebar about the heart here. I'd like to just set that aside and let me do a sidebar about heart. So the heart is a little muscle about the size of your fist right here in your chest. And its job is to pump blood to all of the organs in your body. And if you take all of your arteries and your veins and all of your capillaries and line them up end to end, it's about 26,000 miles. It's way big and too much for this little heart to do. But the way it does it's brilliant. The heart is really more of an electric generator than anything. And what it does is it generates electricity and it puts a charge on the blood cells, so that the red blood cells are actually bigger in size than the capillaries are supposed to go through. So it comes to the capillary, and under normal circumstances, without electricity, the red blood cell wouldn't fit inside the capillary. But with this charge differential, the red blood cell kind of folds up like a cigar and shoots through the capillary in a frictionless system through a charge. So the red blood cell has a little negative charge and the capillary wall has a positive charge, and it's a frictionless system. So this little teeny heart the size of your fist is going to push blood through your entire system because it's an electric generator. And the brain is kind of like it's kind of like a battery. In other words, it'll take that electrical charge and it'll store it in the brain until you want to use it. Let's say you want to move your toe. So it starts as a little thought to move your toe. And then you get a little electrical charge that goes to the motor neurons and goes all the way down to the bottom to the foot, and it moves your toe. And that's through electricity mostly. And that electricity came originally from the heart and is stored in the brain. So getting back to the story, the heart is super important, no doubt. So its said, of course, well, I'm the most important organ because without me, you're not going to get blood anywhere. Well, the lungs also said, well, I think that's very important, Mr. Hart, but, without me, you're not going to have any blood with oxygen. So you can do all the work you want, but without me providing oxygen, it doesn't work. So I think I'm the most important organ. And, they all had a story. The liver says, well, I'm the chemical factory of the body, and I make at least 1,000 different chemicals. And without me, the blood is going to be worthless. So I'm the most important organ. And the brain said, well, no, I'm more important than all y'all because, without me, you can't think. And there's really no point to any of this. And so then it went on down the road and all the different organs had something to say. And then finally it came to the little colon was sitting there saying, well, excuse me, but I think I'm the most important organ. And, all the other organs started laughing and said, well, you're just the colon. What, you're not that important at all. And the colon says, well, I think I am. And just to prove it, I'm going to stop working. Well, it took about 3 days. And, the heart was starting to miss beats and it was starting to get sluggish. And the liver was getting overwhelmed and swollen with toxins. And the brain was getting foggy and it couldn't think straight. And they called an emergency meeting with the organ, say, okay, what are we going to do? This is not working. And the colon, he's just stopped working. And what are we going to do? And so they all decided, well, I think we're going to have to tell the colon that indeed he is the most important organ. So they all went to the colon and says, yes, Mr. Colon, we agree that you are the most important organ. And with that, he unlocked the colon and started to work and everybody was happy again. So, so the moral of the story is to eat for your colon. If you have a healthy colon, everybody's going to be much happier. That's my story. Okay, so it's eating for the colon. And a little bit about diet. So there's only a few major sorts of food types. There's fats, which we all know about. These are, fatty acids. They're long strings of carbons with little hydrogens attached. There's protein, which we know there's 22 there's 22 amino acids. Only 7 of them are essential. Your body makes amino acids except for these 7. And then the other thing is carbohydrate, which is sugar and starch. And so, back in the day, I would talk about diet and say, well, you really don't need carbohydrate. You can live on fat and protein and never have carbohydrate and you can live. Maybe not well, but you can live. But you can't live without fat and you can't live without the essential amino acids without protein. And so that was kind of my working diagnosis for many years, and trying to fix people on their sugar problems and being concerned a lot about, too much starch, which at that time I thought was a problem. I have a new understanding now I'll get to in a minute. But protein, you can actually use protein for energy. The body can change that into a sugar, so you can run off of it, or you can run off of fats as ketones. So, technically speaking, you don't need sugar. We all like it, but it's not essential. So back in the day, we talked about, high protein diets. We have the keto diet, we have the paleo diet. We used to have Atkins diet, and that's not vegan. It's very high in meat and protein. And, people would lose weight on that. I mean, it's not my diet of choice at all now, but just to see that it is there, it's something that, people were doing and were improving their diabetes and whatnot. But when you think of protein, it's rather simple. We have 22 amino acids, and from those amino acids, we make a lot of our structure, and we make a lot of our hormones, some of them, and some of our neurotransmitters, So it is important, but a lot of it we can make ourselves, and some of it we need, but I'm finding we don't need as much as I used to think. I was wrong. And in terms of fats, there are some fats that you absolutely have to be healthy. And these would be the omega-3 fats and the omega-6 fats. The body can't make those. So you have to have a certain amount of those. And my earlier thinking was that the starch, which gets converted into sugar and which you don't need. Well, I have a new understanding of this now. And I'll share a YouTube channel that I ran across only a couple of years ago that changed my thinking about this. And the YouTube channel is Crocs in the Kitchen, and it's a couple. And they were extremely obese and very unhealthy and eating this classic American junk food diet, and were not good at doing well at all. And they had resolved that they were going to become vegan. And to do that, they were going to go on a mono diet. They were going to eat one food and one food only. I think it was for a month, if I'm not mistaken. And so they chose to eat potatoes for a month, only potatoes. And, you can have them boiled, you can have them baked, you can have them boiled, no salt, no oil, no nothing on them, just potatoes, all you want. And after a month, they lost a lot of weight. And a lot of their health indicators became much improved, their diabetes markers. And so this really broke my paradigm of what I thought was healthy, right? So I had to look into this a little bit. How can you just eat potatoes and be healthy? So it just became the pivot point for them, because after doing that for a month and they felt better, they didn't want to eat the American food they had eaten before, and they wanted to eat vegan. Well, what I now understand is that this complex starch is so very important for what? For the gut critters, for the intestinal microbiome, that the intestinal microbes need complex starches for them to be very healthy. So if you're habituated to eat crummy food, then you're going to have microorganisms in your gut that only want crummy food, and you're going to crave food for the microbes in your gut. So it kind of bypasses your brain and your intelligence. So you have to break that pattern. And they did it by eating just potatoes for, I think it was a month. So this kind of destroyed some of my thinking. And I started looking more and more at the gut and how to protect the gut, and particularly our friend, the colon, and what it needs to be very healthy. And so it's fiber, it's complex starch. So what happens with all this starch? I used to think, starch gets converted into sugar, and sugar makes you fat and unhealthy and gives you diabetes. Well, no, a lot of that carbohydrate gets eaten by the microbes in your gut, so that you don't get all that sugar. I mean, you don't get it all. As long as you have healthy microbes in your gut, the starch, the complex starch, is going to go feed these critters, which desperately need. And they've done some experiments where they've implanted fecal material from obese rats into skinny rats, and the skinny rats then became obese. Or you do the same with implanting, microbes from one group of rats that are, say, depressed into another group that aren't, and the other group becomes depressed. So what I'm getting at is the microbiome in our gut has profound implications to how we think and how we care, and our depression and our cravings and our desires. That I know that there is a certain parasite that some people get from cat litter that will make them then more sloppy and more just more sloppy and more filthy, really. And then they are actually have intimacy with more people that they shouldn't be having it. And so that allows this parasite to migrate to other people. So these parasites and microbes in our gut have a huge impact on our brain. So my point is to train your microbiome by having a super good diet, and that includes a lot of really healthy fats, complex starches, fiber, and light protein. You don't need a lot of protein. And if you're doing fasting, like a lot of the yogis do, you actually, on the fast days, the enzymes you produce are going into your whole body and cleaning up a lot of debris. And you actually recycle some of your own protein through that. So, we're finding out how extremely healthy fasting is. So, so my thinking's changed, and I'm much more into focusing on having a healthy colon and getting really, really good fiber and starch, so that my good critters are in my gut, keeps my mind healthy and balanced, and I don't have the cravings that I used to have. So like that. So, all right. So now I would like to, how much, we're just getting started here. Okay, so I like to go through the digestive system, north to south from a Western perspective. And I'll just stop at each area and talk about whatever, what it means to be healthy there, and what some illnesses are there. And so, so digestion, the question I have is, where does digestion start? Where does digestion start?
From the mouth.
What?
From the mouth.
Yeah,
Through
thank you.
saliva.
Okay. Well, I have another opinion on that. Certainly, it starts with the smell. When you have the smell, that will start digestion. But I'll go even before that. I'll say it starts in the kitchen. Starts in the kitchen. A lot of the foods we eat, if they were raw, they would be indigestible. You can't eat lentils unless you cook them, and it's probably better to soak them first before you cook them, because of the lichens, anti-nutrients in a lot of foods. So no, digestion starts in the kitchen. It probably even starts at the farm. The thing that's interesting about humans, I find, is that we're the one species that has to pre-digest food in the kitchen before we even take it into the mouth. And I will say that I would say that ancient peoples would eat many more foods than modern people. If you ask a common person, what are the foods they eat every day? Like, I do a lot of diet histories with people, and I'll see the same foods over and over and over again. I would say that people eat about 20 foods most every day, over and over and over again. But I would say indigenous peoples and peoples in antiquity would eat hundreds and hundreds of different foods at different times of the year when they're in season. So I know some doctors that will, the patient will come in and they'll say, okay, right, give me a list of your 20 favorite foods. Now, these are people who would be at the end of their rope and really in a lot of problems. And so they'll write down all their favorite foods, and the doctor will look at it and say, okay, eat everything except for these 20 foods. And it kind of turns the world upside down, because we're eating the same things over and over again. I have oatmeal maybe most every day. So I think that the point is that we need to get a much more variety in our food. The problem is when we eat the same foods over and over again, we can get sensitive to them. So, but my point is, cooking starts in the kitchen. That's really pre-digesting foods. And we're the only species, well, the only one I can think of offhand that has such an elaborate pre-digestion. And I think that's really how humans really evolved so fast, is with the technology of fire and cooking and spices and making things tasty to our taste, to appease our taste buds, was really a way to condense and get more calories in a smaller amount. So we're not classic herbivores that pretty much eat all day. No, we eat, 2-3 times a day, and it's enough to go the rest of the day where we're doing other things, building cities or whatever. So yeah, in the mouth, yeah, I used to say that too. No, it starts in the kitchen. And then also the digestion starts with the smell of the food, and then the taste of the food. And so why do you think the Supreme Consciousness put the mouth so close to the brain? If God was such a functional person, he would have put the mouth right next to the stomach, and you just feed into your stomach the food. No, there's a reason why the mouth is by the brain, and that is because the taste is sensed through our cranial nerves that go right to the brain, and it actually prepares the GI tract for what's coming. And there's a secret for if you're taking supplements or you're taking herbs, it's best if you can taste the herbs before you swallow them, even chew them. Now, I'll say there's some herbs that you should not chew, and there's some vitamins that you should not chew. There's a few, but most of them you should. So the ones you shouldn't, okay, anything with hydrochloric acid, you shouldn't chew. Some of the really strong herbs that are antiparasitic, yeah, you should probably swallow those. But most of your vitamins and minerals, if you can taste them, you're going to tell the brain, oh yeah, here it comes, and get ready for it. There's another point that I'll share from a teacher. I don't have a reference for this, but the idea is when there's a wound or a damage in your body, there's little chemical messengers that go and end up in your salivary glands. And when the right nutrient comes by, it's tagged in the saliva, and it's helped to carry to the point where it's needed. So anyway, I don't have any proof about that, but there is a benefit for tasting most of the supplements before you swallow them. So then we finally get from the farm to the kitchen, and from the kitchen to the table. We're smelling the food, the whole system's getting ready, and now we put it in our mouth. So then we're starting the internal digestion. And so the mouth is very important because of the saliva. The saliva carries enzymes, mostly enzymes to digest what? Starch. Starch is my new friend, right? So the starch, the amylase in the saliva will help start breaking down the starch. And then, you go ahead and you chew it up as well as you can. You should chew it up very well, and you swallow it, and it goes down the esophagus. So that's really just a tube. Not a lot happens there. There are some pathologies there, but it goes, and then it finally goes through what they call the cardiac sphincter, and it enters the stomach. The stomach is a little sac right below the diaphragm, and it's where the most of the protein digestion happens. So protein needs hydrochloric acid. It needs a lot of acid, and the stomach was designed for hydrochloric acid. It has a protective cell lining, and it has some mucus lining so that it can handle acid so strong that it would burn your skin. So the pH scale, just as a review, so the pH is a measure of hydrogen ions, and its scale goes from 0, or let's say 0.1 is very acid, and then 14 is neutral. I'm sorry, 7 is neutral, and 14 is very basic or very base. So, or alkaline. So there's acid, alkaline. So at the very extreme acid, it can burn your skin. At the very extreme alkaline, it can also burn your skin. The blood is at a pH of about 7.3, 7.4. It's very balanced, a little bit on the alkaline side, very little. Okay, that's your blood. But in the stomach now, where we're going to digest protein, it needs to be very acid. It needs to be acid of pH of 1, 2, or 3. 3 is already a little too alkaline. 1 or 2. And the cells in the stomach make acid at 0.8. That is so acid. But a healthy stomach was made for it. And this healthy stomach is going to put acid in there and help break down the protein. There's other enzyme, protein digestion enzymes. Pepsinogen is released in the stomach, and it's broken down by acid into pepsin, which will then break down the protein. And that's vitally important. I call this the fire of digestion. It also sterilizes the food from parasites and bacteria and all manner of microorganisms that are they're ubiquitous. They're everywhere in the environment. Every glass of water you drink is going to have something in there. And if you have a strong fire in your stomach, you're going to digest them right up. and it's going to be no problem. If you have no acid in your stomach, you know, you're going to be letting in all kinds of microorganisms, and you'll have no protection, and they'll set up housekeeping there. So what happens in the stomach? A healthy stomach is very acid, and it can digest protein just like a furnace. You know, I remember when I was a kid, I could digest a whole large pizza, no problem, and have a beautiful bowel movement the next morning. Well, you know, today I can't quite do that. I'm going to need a little extra help. I'm going to need to take some enzymes, a little hydrochloric acid, and, you know, then I'll be okay. But that's the advantage of youth, right? But you know the digestion of a tiger, where you can pretty much digest anything, and that's youth for you. So we need to keep that system as strong as we can, and we need to make sure that we can make hydrochloric acid. Now we're taking blood at a pH of 7.3, 7.4, and we're going to compress it down to a pH of 0.8, you know, and that takes a lot of energy to compress that in to make it acid for our stomach. And that requires zinc, it requires thiamine, B1, and a little magnesium. And so those are the nutrients that are most important for you to be able to make your own hydrochloric acid. So I see people that are depleted in minerals, and their fire and their digestion just is extinguished. And so if you can't digest protein, so what happens? It putrefies. It's in your stomach, and you can't digest it, and your body goes boom, and you might burp it up, and you taste something, but it doesn't taste acid. It's just that, and it's undigested. And maybe, you know, you hope it's going to go through the system, but it's going to putrefy, and that any manner of problems will start there. So what can go wrong is you don't have enough acid, so you can't digest your protein, so you get putrefaction even in your stomach. And then you'll become protein deficient because you can't digest protein. And then your stomach is not going to have the mucus lining to protect it from acid, so that any little bit of acid can cause an ulcer. And you'll go to the doctor and you say, oh, looks like you have an ulcer. Looks like you have too much acid. Well, no, you actually don't have enough acid, but now you went and burnt yourself. And so you can't take acid because we have to heal your gut first. So there's lots of herbs we can use and lots of supplements that we can use to help heal the gut first before we introduce hydrochloric acid, or we introduce, you know, good protein, and we support it with zinc and thiamine and magnesium. Interesting, this is like epidemic in the West. I mean, there's so many problems with ulcers and reflux and all that stuff. It's a virtual industry. And I'm sure some of you have seen the news about one of the favorite drugs over the years finally went over the counter, Pepsid. Oh my gosh, it causes cancer. You know, well, you know, there's no shortcuts to healing, and you can do it with natural ingredients, but it's going to take some work and some intention and some time. But you can do it, and you do it by providing healing herbs. There was a time when everybody was saying, well, ulcers, that's from the H. pylori. It's a microorganism that's overgrowing. So H. pylori is part of your normal flora. Without acid, it's going to tend to proliferate. And so it's going to be a whole hodgepodge of problems. Reminds me of a story that there's a little sidebar. How are we doing on time? Okay, I think I have, 10 minutes? 10 minutes? Dee Dee? How much time do I got?
Yes.
10 minutes.
Yeah, you still have 10 minutes.
Okay. Well, I'm not going to get to the colon, but that's the bottom line. If you understand my story, that's the whole point of all this. If you have good colon and you have good bowel movements, you've achieved good nutritional health. So I'll skip my story that I was going to do, and we'll keep going. Okay. So from the stomach, the food hopefully is well digested, maybe not. Hopefully it is, and it'll go into the small intestine. And the first part of the small intestine is called the duodenum or the duodenum. Depends on where you went to school. Duodenum. Okay, and it's the nearest part of the small intestine that is actually made to hold some acid. It can handle a little acid, but as the food gets there, the acid or the pH of the, now it's called chyme. It's no longer food, it's called chyme. It's the breakdown of the food, chyme. The pH of the chyme, the acid of the chyme will trigger a reflexive dumping of bicarbonate from the pancreas and enzymes from the pancreas and bile from the gallbladder. And this will neutralize the acid in the duodenum so that you can then process further in the small intestine. Now, I was thinking today how it's funny they call it the small intestine, and then there's the large intestine, because the small intestine, it's not small at all. It's actually big. And the large intestine is kind of small. I don't know why they call it. So the small intestine is, it's about 18 to 20 feet long, right? And it's a tube, right? And it has all of these kind of rolls, they call folds. And on the folds, they have these projections are called villi, and on the villi there's these micro villi. So it has a huge surface area. It's about the size of, well, pick your sport, the size of a basketball court or the size of a doubles tennis court. It's a huge surface area where this is where the rubber hits the road. This is where we're going to decide to absorb or not absorb things. And so they call it the small intestine. To me, it's large. And then once it's processed there, it goes into the large intestine, which to me is small. It's maybe 3 feet, maybe less. But as we have learned, it's the most important organ because the purpose of the colon is to hold the waste material and to absorb water from the colon, and it absorbs some nutrition as well, and then to release it when it's convenient, when it's convenient. So that's why if you're stressed, maybe you don't release your feces. Maybe you hold on to it. Maybe you're traveling and you don't have access to a bathroom. Maybe you're visiting, whatever. Maybe you're stressed. Maybe you're not in a good mental place, and you might hold it too long. Well, what happens is the toxins in the colon actually get reabsorbed into the blood. The blood, all the blood around the large and small intestine, all that blood goes right to the liver to be purified before it goes to the heart. So if you're going to hold your waste material too long, you're going to be reabsorbing all the toxins you thought you just got rid of, and it's going to go to the liver, and it's going to make all kinds of problems for the liver. So you need to have, one, better 2 or 3 bowel movements a day. Ideally, I'm happy if I get one, all right? One, I'm just saying, but, ideally you'd want more. Complete, full evacuations. So, okay, I'm jumping all over the place here. I want to go back a little bit to the small intestine because it's pretty important too. It might be the most important organ right next to the colon, because it is where we absorb the bulk of our nutrition and where we keep out the toxins, right? So when the chyme leaving the stomach enters the small intestine, that acid, that pH is going to spark the release of neutralizing bicarbonate and digestive enzymes. And if there's any fat in there, hopefully there is, you're going to also release the bile from the gallbladder. So bile is a liquidy substance made in the liver, and its job is to emulsify fat or break down fat, kind of like soap. It's going to break down the fat globules into little pieces so that the enzymes can get to them and absorb them. It's tremendously important. So people on the low fat or no fat diet, I think it's a big mistake. What happens is the gallbladder doesn't empty. It has to have some fat in there to empty. So what's so important about that? Well, let's talk about detox a little bit. So we can say there's water-soluble toxins and there's fat-soluble toxins. So water soluble, that's pretty easy. You can sweat out water soluble toxins. You can uh, pee them out in your urine. You can even breathe them out with your breath. Water soluble, not a big deal. Do saunas, drink a lot of water, flush your system. That's not a big deal because we have ways to get rid of water soluble toxins. Fat soluble toxins are another problem. If it's fat soluble, it's not going to go through your urine or your sweat. It's going to have to go, well, you can store it in your fat cells, or you can eliminate it into your gallbladder with your bile, into the intestines. So a lot of people store it in their fat cells. And that's why a lot of people, when they're losing weight, they don't feel so good because they're releasing toxins that have been stored, maybe decades ago are all being released. So, fat loss, sometimes people plateau because for whatever reason, that's a weight they used to have, and they might have dumped a lot of toxins there. So they kind of slow down with their weight loss. So, you'd rather get them out if you can, right? So the way out is the liver. I was talking to Dada a couple days ago about the phase 1 and phase 2 detox, and actually, my dyslexic self, I got them backwards. So when there's a fat soluble toxin, it's processed in the mitochondria through oxidation. You try to combust it, right? So any fat soluble toxin that's stuck there, it'll go to the liver, and you're going to do phase 1 detox. You're going to try to combust it in the mitochondria. You're going to add oxygen. You're going to oxidize it. That creates a lot of free radicals, but never mind, you got to get the toxins out, right? And so this oxidative toxin, usually in the liver, it could be done other places, but let's say the liver, well, then it's oxidized now. And so it's an intermediary product that needs to then be processed further. Sometimes that intermediary toxin is actually more toxic than the original one. It's been oxidized, sometimes less, just depends. So then this intermediary product has to go through phase 2 detox. And that's where the liver is going to add something. It's called conjugation. It's going to add a methyl group. It's going to add a sulfur. It's going to add a glycine. It's going to add something to this toxin to make it less toxic so that the body can manipulate it without being damaged. And those phase 2 toxins end up hopefully in the gallbladder so that the next time you have fat in your chyme, it's going to squeeze out into the small intestine. And now you have your toxins that you're trying to get rid of. They're in your intestines. You want to make sure that you can get them out with your next bowel movement, right? So hopefully the small intestine will be able to put a block so you don't absorb it. It's going to go to the colon, and hopefully you're going to eliminate it that day as soon as possible, get it out. If you don't, you're going to reabsorb the toxin. It's going to all go back to the liver, and you're just going to have this whole cycle over and over and over again. So when patients come in to see me, I'm asking, how are you sleeping at night, and how's your bowel movements? Oh, fine, it's fine, yeah, okay. And I ask a little more. I say, oh yeah, I take Cascara Sagrada every night, and I got a great bowel movement, and I take Nyquil so I can sleep all night. So well, these are bad ideas. So, these are bad ideas. Nyquil has Benadryl in it, and it actually has a strong association with dementia. So you don't want to be doing these artificial things to help you sleep at night. If you're not sleeping at night, that's something that needs to be looked at. If you're needing to take things to move your bowels every day, it ain't fixed yet. That's not a solution. That's okay. It's a Band-Aid, but we need to really get all the system working. So the point of view is, if you have a problem down south in the colon, you need to look up north to see where the problem is. Is it the foods you're taking? Is it the way you're processing? Are you deficient in enzymes? Do you have a bile problem? Do you have gallstones? Do you need hydrochloric acid? Do you have microbial overgrowth in your small intestine? You need to find out where the problem is and address that, so that in the end, you'll have wonderful bowel movements every day without a lot of effort. So I'm kind of running to the end of my my talk here. I think I skipped over a lot of things, but it's the big point is you need to eliminate, you need to detox. That should be an ongoing process, and you need to make sure your upper GI system is working well. And there are solutions for all of this. Um, I'm not sure I'll be here at the very end, but I'm happy to talk to anybody that wants to. You can find on my website. It's www.healthworkspdx.com. Healthworks with an S. PDX is the airport name for Portland, Oregon. That's kind of where I'm more or less located, more or less. Healthworkspdx.com. And my email is pdxhealth@gmail.com. That's PDX for Portland, health@gmail.com. And, you know, I'm happy to, you know, talk to anybody that has any questions or whatever. And I think with that, I think I've come to the end of my time, and I respectfully hand it back to Dee Dee. Thank you.
Thank you so much, Dr. Michael Owen. That was so enlightening and very interesting topic that you shared to us. So now we go to question and answer session. But before that, I would like to announce something. We're going to have our third speaker, Dr. Erica, and she will talk about the conscious eating. And during her session, there will be some a little bit exercise. So I would like you all can prepare something with very easily for you to grab, maybe something like resin, chocolate chips, blueberry or nuts or anything that you have. So any kind of food that you have. Erica's speech. So